What is up guys, welcome back to another Cambridge Realm video. Today we are going to solve some topic wise MCQs of AS level physics, and the topic is going to be physical quantities and units. So without much further ado, let's get started. So the first question is, which of these is an SI base unit? So current is actually not a unit, it's a physical quantity. Ampere would be the unit. Gram is a unit, but it's not a SI base unit. The SI base unit for mass is actually kilograms. Kelvin is indeed actually the SI base unit that we're looking for. It's the SI base unit for temperature. So the answer for 1 is C. Right. So let's move on to the next one. Which pair contains one vector and one scalar quantity? So displacement, we know that displacement is a vector quantity, and acceleration is also a vector quantity, since acceleration is the rate of change of velocity, which is also a vector quantity. Force is once again a vector quantity because it gives both the direction as well as the magnitude. Kinetic energy, on the other hand, is a scalar quantity because it does not give us the direction. Momentum and velocity are once again both vector quantities, and power and speed are both scalar quantities because they only give you the magnitude, not the direction. So therefore the answer for 2 is B, force and kinetic energy. When a constant braking force is applied to a vehicle moving at speed v, the distance d moved by the vehicle in coming to rest is given by the expression d is equal to kv square, where k is a constant. When d is measured in meters and v is measured in meters per second, the constant has a value of k1. What is the value of the constant when the distance is measured in meters and the speed is measured in kilometers per hour? Right. So in this one, we've got this formula, d is equal to kv squared, and right now, so k is equal to d upon v squared, and right now it's being measured in meters by meters per second squared. What we need to do is convert this to meters upon kilometers per hour squared. 1 meter is 1,000 kilometers. So therefore, and 1 meter would be 1 upon 1,000 times kilometer upon 1 upon 3,600 of an hour. Since there are 60 seconds in a minute and there are 60 minutes in an hour, so therefore the number of seconds in an hour is 60 times 60, which is 3,600. So that once we simplify that, you're going to get 3,600 upon 1,000, which is 3.6. So now we know that 1 meters per second is actually equal to 3.6 kilometers per hour. Let me just clear out the screen for a minute. So now we know that if we must convert this value into meters per kilometers per hour square, then that means that we must simply divide it by, multiply it by 1 upon 3.6 squared. since that's the coefficient that we must multiply this value with in order to get us to kilometers per hour. And since there's a square over here, we also need to square the value over here. And if we just calculate that, 3.6 square brings us to 1 upon 12.96, and if you just simplify that, you'll get 0.07716, which, if you can see, once we round it off, it actually comes down to answer A, which is 0.0772 times K1. So therefore the answer is A. Right, so let's move on to the next one. What is a reasonable estimate of the average gravitational force acting on a fully grown woman standing on Earth? So let's just say that the average weight of a woman is around 65 kilograms, and 1 kilogram is actually equal to 10 newtons. So we just have to divide each of these values by 10 and see if that's a reasonable amount. So 60 upon 10 is only 6 newtons, which is not accurate. I mean, there won't be any fully grown woman who would be only 6 kilograms. Like, that's not possible. So that's wrong. Option B is 250 newtons, and if you divide that by 10, you'll get 25 kilograms, which is still light. Option 3 is 350 newtons, that is 35 kilograms. Once again, that's not appropriate. And lastly, we've got 650 newtons, which when you divide by 10 is going to give you 65 kilograms, which seems like a pretty reasonable estimate. So the answer for 4 is D. So which definition is correct and uses only quantities rather than units? So density is mass per cubic meter is the correct definition, but it is using units, as in cubic meter is actually a unit. Potential difference is energy per unit current. Potential difference is the definition itself is wrong, because potential difference is actually the energy per unit charge, not the energy per unit current. So those two can be ruled out. Pressure is force per unit area. So pressure, the definition is correct, and it is also using only quantities. Speed is distance traveled per second. Once again, the definition is correct, but it's using units. So our answer for the fifth one is C. The average kinetic energy E of a gas molecule is given by the equation E is equal to 3 upon 2 K times T, where T is the absolute Kelvin temperature. What are the SI base units of K? Right, so we know that K is equal to E upon T. We can ignore the 3 upon 2 since that's just a constant and it won't really affect any of our workings. So, and we also know that, for instance, if we must calculate energy, so we can use the formula for kinetic energy, because that's what we're talking about right now, which is half mass times velocity square. Right, so these are all your quantities. Now let's move on to the units, and I'm going to do this in a different color so that you don't get confused. So the units for SI base units for energy is going to be the units for mass, which is kilogram, and then the units for velocity squared, which is meters per second squared. And if you simplify that, you're going to get kg meter square second raised to minus 2. Now we have to divide that by the SI base units for T. So we just add K to the negative 1, which is per Kelvin. And so that's our final answer. Now which one of these options match? Option D. Yeah, we've got option D. So the answer for 6 is D. the arrow represents the vector r. Which diagram does not represent r as two perpendicular components? So if you can see, r is this vector right over here, and in sort of a general sketch it looks like this. So you can, like in this question, it's best to just draw out all the possible solutions. So a would be something like this. Wait, let me just change my color over here so it's easier for you guys. This would be option A, which seems okay. Like, yeah, that's okay, that's possible, and it does represent r. This would be option B, and yes, this too is possible, because you can split r into these two different components. This one would be very small and this one would be extra long. I mean, I've not really drawn it to scale. It would actually be smaller, like somewhere around this point, and not this extra stuff. Now option C would not be possible, because you can't really, it's not actually being split, you're just essentially tracing it on top of this. So that would not be possible because you're not splitting it. And option D is also possible because you can split it in this particular way. So therefore our answer is option number C, since that was the only one that was impossible to do. Right, let's move on to the next one. Which statement includes a correct unit? Now we know that energy is only in joules, so the unit for energy is joules, which is a J. The unit for force is newtons, not Newton seconds. Now momentum is a tricky one, because many of you may assume that momentum is only the mass times the velocity, which is kg meters per second. However, if you remember the the impulse equation, that is force times time is equal to mv minus mu, which basically means that the force times the time is equal to the change in momentum, or delta momentum. So therefore momentum has the same units as force multiplied by time, which is Newton times second is equal to Newton seconds, and therefore the answer for 8 is C. Right, let's move on to the next question then. What is the joule in SI base units? So once again, we've got to basically write out the formula first. The joule is the unit of energy, and whatever you do, it's like whichever formula you use, whether it's the gravitational potential energy or the kinetic energy, you're going to end up with the same SI base unit. So let's move on with kinetic energy. So that's half mass times velocity squared, and you can ignore the half because that's a constant. So that, once you write it out in units, is kilograms meters per second squared, which is kg meter square per second square, which is option number D. So the answer for 9 is D. The speed of an aeroplane in still air is 200 kilometers per hour. The wind blows from the west at a speed of 85 kilometers per hour. In which direction must the pilot steer the aeroplane in order to fly due north? Now this is a tricky one. In order to solve this, we must use a vector diagram. So it's saying that the wind blows from the west at a speed of 85 kilometers an hour. So it's blowing from the west like this at 85 kilometers an hour, and we need to go due north like this. That's going to be this should be our resultant vector. Now now of course, in order to move due north, the pilot will have to move at a certain angle to north, which would be like this. And what we are being asked is, what is this angle? Let's just call it theta. So the speed of the airplane in still air is 200 kilometers an hour. So we can label this side as 200. And now we can use trigonometry to solve this. So this is gonna be sine theta is equal to 85 upon 200, because, well, this is the opposite and this is the hypotenuse. So sine theta is equal to opposite upon hypotenuse, and then theta would be sine inverse of 85 upon 200. And let's just use our calculators. So that comes out to 25.15, which can be rounded off to 25.2 degrees. And in which direction is this? This is to the west of north. So therefore our answer for 10 is D.